All right, Algebra, welcome back. I'll put myself up there. We are sort of continuing quadratics for just a little bit today. We're going to look at some different forms of quadratics, and then after today, we'll take a break from quadratics and we'll come back to it in about 2 weeks or so. But this is going to be our last lesson on quadratics for the time being, and then we'll come back to it. And we're going to split this lesson up into 2 shorter pieces. So we're going to start with this warm-up. Label the y-intercept, x-intercept, and vertex on the parabola. Pretty easy. I just have to figure out where's my y-intercept, where's my x-intercept, and where is my vertex. Well, the y-intercept is actually not so easy because if we look, our function doesn't quite actually cross on our graph. So we'll actually come back to that one. So y-intercept we'll come back to. X-intercept should be pretty easy. I see I cross my x-axis right here, and I cross my x-axis right here. So my x-intercept is going to be, 2, 0. My x-intercept is at 2, 0, and 4, 0. I have 2 x-intercepts because I crossed the x-axis twice. So those are my 2 x-intercepts. What about the vertex of my parabola? Once again, also pretty easy. We're familiar with that. That's our turning point of our quadratic, so our vertex is going to be located at 3, -1. Now let's go back to the y-intercept. How can we find that y-intercept when it's off the graph? Well, I do know that quadratics always have that consistent pattern where starting from my vertex, if I go over one space in either direction, I go up 1. So we go over 1, up 1. If I go over 2 spaces, I go up 1, 2, 3, 4. And that works in both directions. 1, 2, 3, 4. So if I go over 2, I go over 4. If I go over 3 spaces from my vertex, going over 1, 2, 3, I would go up 1, 2, 3, 4, 5, 6. Well, how much am I going to go up if I go 3? Well, let's remember, quadratics are always about squaring values. It's x squared. So 1 squared is 1, 2 squared is 4, 3 squared is going to give us 9. So we need to go up 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're going up to 9. But now let's think about it again. This distance here is 9. If I'm starting at -1 and going up 9, I'm going to go up to 0, 8. So 0, 8 is going to be my y-intercept. Now let's write an equation for this transformation. So we know equations, we know our vertex form of a quadratic is always y equals a times x minus h squared plus k. That was our vertex form we practiced over the past couple days. So we just need to fill in each of these values. We know h and k represent our vertex, h being the x-coordinate of the vertex, k being the y-coordinate of the vertex. So I know I'm going to have y equals some number times x minus h, so it's going to be -3 because my vertex coordinate is 3, squared plus k. So plus -1, which is the same as having -1 if I write that. Now, what's that number in front? What's my a going to be? Well, the a is always the number that determines how wide our parabola is, whether we're wide or skinny or whether we're facing up or down. In this case, we're facing up, so we know we're going to be a positive value because once again, if we think about it, positives are happy, so we're smiley, while negatives are frowny, we're upset. If I do look at my pattern, though, I'm going over 1, up 1, over 2, up 4, over 3, up 9. We have that consistent parabola pattern. And it's not changed at all. It's just that normal over 1, up 1, over 4, or over 2, up 4. If it were to be like over 1, up 2, over 2, up 8, then that would be double that pattern. We know we'd be multiplying. So we always multiply by that a value. But in this case, my pattern isn't changed at all. So I know I'm only multiplying by essentially 1. So I really don't have to have a number in front of there. I could just leave it as y equals x squared minus 3, or y equals x minus 3 squared minus 1, and that would be perfectly okay. Let's move on. Which function, or which quadratic function in the vertex form can be represented by the graph that has a vertex at 3, -7 and passes through the point 1, -10? So which of these quadratics function in the vertex can be represented by the graph that has a vertex at 3, -7? So let's start with our vertex. 3, -7. So we know our vertex is always opposite of h. K is our vertex. So if I have 3 here, I know I'm looking for -3 in my vertex, and I'm looking for -7 as my k. So thinking about our y equals a quantity x minus h squared plus k, I know I'm going to have -3 and positive, so -3 and -7. So I know I have to be one of these two functions here. It can't be this one because this is +3, and can't be this one because that one's also a +3. Oh, wait, well, it's not even this one because this is a +7. So we're actually good. So we just need this part. We don't have to even need that extra part. Now, one way that we could use this extra part in case we needed it is we could plug in, if we think about our function being y equals x, we know it's x minus 3. Sorry, let me rewrite that. Let me rewrite this. I'm all over the place. All right. If we did want to use this to help us solve, we know our function is y equals a times x minus h squared plus k. And we know we have it written as y equals a times x minus 3 squared plus minus 7. Sorry, it's -7. I keep thinking it's +7. It's -7 as -7. So let's say there were two that, let's say this was -7, and we had to guess between these two. We don't know which one it is. In order for us to figure out what the a is, what we could do is we could see, okay, I know this is my x coordinate, this is my y coordinate. I can plug my x and my y in the function. So I can plug -10 in for my y and 1 in for my x, and I could use that to help me solve for my a in my function. I could use that to help me solve for a. Now, I would have to think, okay, what's 1 minus 3? Well, that's -2. -2 squared is 4. So this would be like a times 4 minus 7 equals -10. Well, what's a times 4? That's the same as 4a minus 7 equals -10. And this would just be a multi-step equation where we would have to inverse our 7, divide by 4, and we would get a to equal -3/4, which we would see then, oh, okay, I know I need to use that one. But luckily, we didn't actually have to do all those steps in this problem because our vertex was able to give us enough information. But in case it wasn't able to give us enough information, as long as we know one point, we can easily find that a as well by solving for it just like any other variable. All right, now we're going to move on to what the meat of this lesson is going to look like. All right, so you're going to do an exploration activity similar to the one we did the other day on Monday, Tuesday. In this activity, we're going to look at some different forms of quadratics. So we've talked about one form of quadratic so far, the vertex form. There is actually 3 forms of quadratics. There's the vertex form, there's the factored form, and there is the standard form of a quadratic. So we're going to look at those other 2 as well, along with the vertex form, and try to figure out why is it important for us to have 3 different forms of a quadratic? Why don't we just use vertex form? Like, why do we have to have 3 different forms? And it's because each of these forms are helpful in different ways. So our goal today is to try to figure out, okay, which form is helpful with which key features? Because each of them are going to identify key features for us. Which ones help us with which? So in this activity, this is what you're going to do. For each of these functions, you're going to get a function. You need to first use Desmos to graph the function. So you're going to graph your function in Desmos, and we're going to look at it. Then you're going to fill in the table of key features. So we're looking for the y-intercept, x-intercepts, vertex, other x-intercept. We want to fill in our table for these key features. And then we are going to compare the equation and the table and look to see if we notice any patterns. So step number 1, we're going to do this first one together just to give you an example. Step number 1, let's look at this function. So I graph it on Desmos. If I can get my thing. Come on, graph. Maybe. There we go. Here we go. Oh, it's coming up like 8 times. All right, so I have this function. So I need to look at what are my key features of my function once I get it typed into Desmos. So I have my y-intercept at 0, 3, my x-intercept at 1, 0, my vertex at 2, -1, and my other x-intercept at 3, 0. So let's fill in our table. So our y-intercept was 0, 3. Our x-intercept was 1, 0. Our vertex was 2, -1. And our other x-intercept was, 3, 0, I believe. 3, 0. So we can easily find those from Desmos. And now let's look for some patterns. Do I notice any patterns showing up between this equation and my factored form? Well, something I might notice is I see I have x minus 3 in here and x minus 1. Well, I see my x-intercepts. I have a 1 and a 3 for my x-intercepts. So maybe something along with numbers in equation match x-intercepts. And so you keep going through these. So you look at another, there should be multiple factor forms, there's multiple vertex forms, there are multiple standard forms. And we'll look, okay, what patterns do you notice showing up from the equation and the table? Do you notice anything being consistent? And at the very end, you are going to look at each of them. You're going to look at the factor form, and you'll go to all your factor forms and see, okay, what patterns did I see were consistent with all my factor forms? Then we're going to look at a vertex form. What patterns did I see were consistent with all my vertex forms? And then lastly, we'll look at our standard form and see what any standard form patterns that were consistent. So you're going to jump and do that right now. It should be on Schoology, ready for you to go. Let me know if you have any questions or are confused on anything. And we'll pause this video here.